Okay, so welcome to the explanation of general air pressure and local winds. So first of all, so air pressure in general. So air pressure is just the force of air pressing down on the earth. Okay, so generally speaking, air pressure is higher when particles are closer together. Okay, so how does that explain what happened with the demonstration, the fabulous demonstration with the bottle? So I'll try and make an attempt to draw that bottle. All right, and there's that bottle, and then here's this piece of paper. And when I blew in on the piece of paper pushed out of the bottle, was pushed out of the bottle. And that's specifically actually what happened. So the paper was pushed out. Basically because in this bottle, the bottle was already full of air. I allowed air to come in through here. When I blew in air, what happened was the air pressure was now higher here because before it was just equal. Now I made the air pressure higher here, and this air forced the piece of paper out of the bottle. So the paper was pushed out because the air pressure in the bottle when I blew in it increased when I blew in. And what happened is I added more air. And then the pressure in the bottle, the air pressure in the bottle, was larger than outside of the bottle. So the air, so what that we can conclude there, therefore air particles will move from areas of higher pressure to areas of lower pressure. Okay, so kind of think of, like if you're kind of in a crowded space, you might want to move away from the crowded space. So that's kind of what air does, is it's like condensed and it's really tight together. And if it's tight together, then it'll want to move to a place where it isn't as tight together. So that's what happens. Okay, now how does this relate to warm and cool air masses? I guess I didn't really need to underline that. So, when we talked about, when you watched that video about warm and cool air masses and fronts and kind of when they meet, this is kind of how they interact and part of why they interact that way. So first of all, in a warmer air mass, particles, kind of are moving around more, and they spread apart. Okay, this means that warm air masses are less dense. Okay, so because of that, they're less dense, kind of the same as the bottle here, that less density or fewer particles in the same area means that they have lower air pressure. Okay, the opposite is true for colder air. Okay, colder air is more dense because the particles are closer together. So therefore it has higher air pressure. Okay, so watching kind of what this means for smaller areas, so not so much globally, although this does work globally, but we'll talk about that in the next video. So in kind of a local area, in a smaller area, maybe a town or a city, or even a state technically, what you have is, let's say we have the ground here. So this is my fabulous representation of the ground. Okay, and then you have right above the ground, so that ground gets heated by the sun. Okay, the ground gets heated by the sun. So then you have this warmer air above the ground, because once the ground gets heated by the sun, so by radiation, then what happens is the air above it gets warmed by convection. So there's this conduction, excuse me. There's the warmer air above the ground because it was heated by conduction from so that heat came from the earth. So that heat on the ground heat then warms the air right above it. And above that, though, higher up, we have cooler air. Okay, that isn't getting as heated by the ground. Okay, so what happens here? So you have this cooler air that's higher up and this warmer air above the ground. Now, the cooler air and the cooler or more dense air will sink. So it goes from an area of high pressure to an area of low pressure. Okay, and the warmer, more dense air will rise. Warmer, less dense air. Okay, so rises up and this movement of air here okay, hopefully you remember it's called the convection current. Okay, but this movement of air, due to differences in temperature, that movement is wind. Okay, specifically, this is a local wind. And other examples of local winds are land and sea breezes, which I have attached some different readings if you would like to do any, or if you'd like to remind yourself how land and sea breezes work, but specifically we don't need to go over all that. So when you have the chance, then watch the next video that kind of introduces the same concept again and kind of a cooler way of looking at it that we've already seen before. And then we'll talk about what happens globally as far as the same idea, but on a global scale. Thanks for watching.